webinar. Let me introduce myself. My name is Mosam and I am a part of TeamLease ELS team. So today we are going to take up a webinar on the NLP, that is natural language processing, for which the today's topic for us will be So we will be covering the today in topic as in the learning outcome for this will be that understanding the NLP and working with the sentimental analysis, on which the Smith, our SME trainer, will take you through the different aspects of it that includes the text classification, doc clustering, and sentiment analysis. Coming to Smith's profile, Smith comes up with 8+ years of experience in with expertise into the different domain like data science, machine learning, Apache, Kafka, Azure, Python, MongoDB, and many more. He has delivered the trainings into the multiple corporates to big brands and for the professionals. His skills and expertise will help us you to understand the subject today. I hope like you will enjoy and gain up the learning from the which has been provided in this 1.5 hour of a session. So if do you we will have the question answer round at the end, and further to that, if you have any session questions later, then you can write back to us. I'll connect with you at the end of the session. Smith, over to you. If you can present your screen and we can start the session.
Okay. Thank you, Mosam. All right, so I hope my screen is visible to everyone. So good afternoon once again to each and every one of you. My name is Smit Shah and I will be your mentor for today. As Mosam already mentioned, today's webinar is going to be focused on NLP, right? So let's go ahead and let's dive into it. Before diving, just to give you a brief introduction about myself. As I mentioned, my name is Smit Shah, and I've been in the data science field since the past 8 years. I'm a Microsoft certified trainer, as well as a Microsoft certified data engineer, a Microsoft certified data scientist, a Microsoft certified machine learning engineer, and a Microsoft certified AI engineer as well. And I've delivered training to many clients, including Deloitte, LTI Mindtree, Capgemini, and many more. So yeah, in total, I would have trained more than 10,000 data science students up till now. So yeah, that's just a brief introduction about me. With that out of the way, let's move forward and let's focus on the webinar for today. So as you know, today's webinar is going to be focused on natural language processing. In short, you can call it NLP. So let's go ahead and let's dive into it. So guys, NLP is a field of machine learning. So before we go ahead and understand what is NLP, it's important to understand what is machine learning. So let's take a few minutes to understand the basics of machine learning. So what is machine learning? If anybody asks you the definition of machine learning, you will say machine learning is a set of tools that is used for two purposes. First purpose is to get inferences from the data, and second purpose is to get predictions from data. By inference, we mean insights. Okay. By inference, we mean insights. So let's say looking at data of Walmart, I come to know that more people are coming in uh, on Sunday as compared to Tuesday. So I will tell my manager to be ready on Sunday that, okay, it seems that looking at the uh, data that we have, it seems more people are buying things on Sunday, more people are coming into Walmart on Sunday. So I, being a Walmart employee, would tell my manager to be more prepared on that particular day, right? So you can use machine learning to obtain inferences from data, to obtain insights from data. Second purpose to use machine learning is to obtain predictions. So let's say I want to predict something about the future. So let's say based on how it has rained till the year 2023, I want to predict how it will rain in the year 2024, right? So that's an example of prediction. So if anybody asks you the definition of machine learning, you will say machine learning is a set of tools that is used for two purposes. First purpose is to get inferences from data. Second purpose is to get predictions from data. Now, how do we do that? How do we get inferences and predictions from data? We do that by using something called a machine learning model. Okay. How do we get inferences and predictions from data? We do that by using something called a machine learning model. Now, what is this machine learning model? Let's look at the definition. So, guys, a machine learning model is nothing but a statistical representation of a real world process. In simple words, we are trying to simulate a real world process using some statistics or using some mathematics. Let's go ahead and let's understand this complex definition with the help of an example. So let's suppose I have housing related data. So I have information about some of the houses in my locality. So I have obtained their information about area. So I have information about area of the house in square feet. And I also have information about the price of that house. Okay. So let's say the first house that I surveyed had an area of 100 square feet and the price was, let's say, $1 million. Okay. The second house that I surveyed had an area of 200 square feet and the price was, let's say, $2 million. The third house that I surveyed, let's suppose, has an area of 300 square feet and the price was $3 million. Now, I have a question for you. Okay, let's suppose we have a fourth house with us. Okay, let's suppose we have a fourth house. The area of this fourth house is equal to 350 square feet. Can anybody predict the price of this fourth house? Can any one of you in the chat predict the price of this fourth house? What do you think? What, according to you, would be the price of this fourth house? Okay. So Amit, Harishankar, Vignesh, uh, then one more student over here have given the answer. And as you guys have mentioned that according to you, you are guys are predicting that the price of this fourth house will be somewhere around $3.5 million. Okay, so you gave me a prediction, right? So over here, let me ask Uday. So Uday, can I say that you gave me this prediction for this fourth house? Okay. Now, in order to arrive at this prediction, do you use some mathematics in your head, Uday? In order to arrive at this prediction, did you use some mathematics in your head? Yes, right, Uday. Although Uday over here, it was a very basic data on which you were working. That's why you applied very basic mathematics. But you did apply some mathematics. So Uday, Ankit, Sudarshan, everybody in the chat who have given the answer, everybody who have predicted the price of this fourth house over here, have applied some mathematics in your head. Okay, that's exactly what a machine learning model does. A machine learning model also tries to simulate what would happen in the real world by using statistics or by using mathematics. Okay, just like you guys use mathematics to simulate what would happen in the real world, similarly, a machine learning model also does that. It was just that this particular data was very simple. That's why you applied very simple mathematics. On the other hand, a machine learning model would apply little complex mathematics. So what all mathematics will it apply? What all mathematical formulas will be used? All of that will learn. Don't worry. Okay. But up till now, we have covered two definitions. First definition was what is machine learning? So if anybody asks you what is machine learning, you will say machine learning is a set of tools that is used for two purposes. First purpose is to get inferences from data. Second purpose is to get predictions from data, right? Now, how do we do that? How do we get inferences and predictions from data? We do that by using something called a machine learning model. What is a machine learning model? It is a statistical representation of a real world process. That means we are trying to simulate a real world process using some statistics, using some mathematics. Okay. Now, before you make any machine learning model, okay, before you build any machine learning model, there are two important notes that every one of you should remember. Okay, so before we build any machine learning model, there are two important notes. First note is that in order for making a machine learning model, we need some data, and that data needs to have some rows and some columns. So you might wonder, what if we have data like images? In that case, what will I do? Well, even that image data needs to be converted into rows and columns. So whatever data you have, if it's already in rows and columns, good. If it's not in that particular format, you convert it into rows and columns. Okay. So remember that in order for any machine learning model to work, you need some data, and that data should be in the form of rows and columns. Okay. So remember this note number one. Let's move on to our note number two. Note number two is that the columns in the data will be of one of the two types. Either a column will be called a feature column or a column will be called a target column. Now, what is the difference between a feature and a target? Well, a feature column is that column that helps me to predict, whereas a target column is a column that I want to predict. Okay. So suppose I have housing related data over here on and have a look at this data. On this data, my first question to each and every one of you is on this data, can I build a machine learning model? Yes or no? What do you think? On this data, can I build a machine learning model? Vignesh says yes, right? Hari Shankar, Uma, Amit, all of you guys are saying yes. And you guys are absolutely right. Why? Because as per our note number one, in order to make a machine learning model, we needed some data, and that data should have some rows, some columns. And here in this data, we do have some rows and some columns, right? So on this data, we can build a machine learning model. Okay. Now, we know the columns in the data will be of one of the two types. Either a column will be called a feature column or a column will be called a target column. Feature column is that column that helps me to predict. Target column is that column that I want to predict. So suppose if I want to predict price, then guys, price will be which type of column? If I want to predict price, then price will be which type of column? Any suggestions? Uday, Vignesh, Uma, all of you guys are saying it will be a target column. You guys are absolutely right. This price column will be my target column. I'll do one thing. I will just mute everyone. I guess by mistake, some student had unmuted their mic. Okay, anybody. Anyways, coming back to our explanation. Over here, we know on this data, we can build a machine learning model. Why? Because in order to make a machine learning model, we needed data having some rows and some columns. And here on the screen, you do have some data having some rows and some columns. Perfect. Now we also know that the columns in the data will be of one of the two types. Either a column will be called a feature column or a column will be called a target column. Feature column is that column that helps me to predict. Target column is that column that I want to predict. So if I want to predict price, then price will be my which type of column? It will be my target column. Exactly as mentioned by every one of you in the chat over here. Fine. Fine. Then let me ask Naresh. Naresh, what do you think? Does city help you to predict the price? Does city information help you to predict price? What do you think, Naresh? Yes, right. It does help you to predict price. For example, in a city like Mumbai, the price would be high, whereas in a city like, let's say, Raipur, the price will be slightly low, right? So city information does matter. Okay. Similarly, does square feet information also help me to predict price? Yes. So since these two columns, square feet and city, are helping me to predict price, since these two columns, square feet and city, are helping me to predict the target column, since these columns are helping me to predict the target column, these columns will be called my feature columns. Okay, these columns will be called my feature columns. So remember that the columns in the data will be of one of the two types. Either a column will called a feature column or a column will be called a target column. Feature column is that column that helps me to predict. Target column is that column that I want to predict. So if I want to predict price, then price will be my target column. And since square feet and city help me to predict price, they will be called my feature columns. Okay, fine. With that out of the way, let's move forward. So up till now, what have we done? First, we looked into the definition of machine learning. Second, we looked into the definition of a machine learning model. Third, we focused on these notes that are written on the screen over here. So these are the three things that we have done up till now. Fine, let's move forward. Now, it's very important to understand the different types of machine learning models. Okay, we know what is a machine learning model. Now let's understand the different types of it. So guys, there are many types of machine learning models in the market. After every 6 months or so, a new type comes into the market. Okay, so there are many types of machine learning models. However, 95% of the work in the machine learning industry is done on these two types only. The first type is called supervised machine learning model. Second type is called unsupervised machine learning model. Remember, there are types apart from these two as well. Okay, but 95% of the work in the machine learning industry is done on these two types only. That's why in this lecture, we'll focus on these two types only. Okay. But remember, there are other types also. And after every 6 months, a new type comes into the market. Okay, fine. All right. So remember that there are different types of machine learning models. However, today we are going to focus on two. First is called supervised learning model. Second is called unsupervised learning model. What is the difference between the two? Well, in case of a supervised learning model, the data that I'm using has features and target both. Whereas in case of a unsupervised learning model, the data that I'm using only has features. It does not have target. Okay, so remember that. What is the difference between supervised learning model and an unsupervised learning model? In case of a supervised learning model, the data that I am using has features and target both. In case of an unsupervised learning model, the data that I am using only has features, it does not have target. Now, supervised learning models are further divided into two types. First is classification model. Second is regression model. What is the difference between a classification model and a regression model? Well, in case of a classification model, the target column has finite set of possibilities, whereas in a regression model, your target column has infinite set of possibilities. So let's go ahead and let's understand the difference between a classification model and a regression model with the help of an example. So suppose I have a column with me called dice roll. I have a column with me called dice roll. Okay. And what I'm doing is whenever I roll the dice, whatever value I get, that value I'm storing in this column. So let's say I'm playing a game of dice with my friends and I'm rolling a dice. So let's say in the first time, on the first time when I roll the dice, I got the value 3. Then next again when I roll the dice, I got the value 1. After that, when I roll the dice, I got the value 6 and so on. Okay. Now, a question to each and every one of you. The question is, when in this dice roll column, how many possibilities we have? So when I roll a dice, how many possibilities do I have? How many values can I get when I roll a dice? Monty, Harishankar, Sudarshan, all of you guys are saying we have six possibilities, right? When we roll a dice, right? As you mentioned, we have six possibilities, right? When we roll a dice, either we can get the value 1 or 2 or 3 or 4 or 5 or 6. Apart from these six possibilities, we don't have anything else. So can I say, Mandeep, that dice roll column has finite set of possibilities? When you said, Mandeep, that we have six possibilities only, right? When I roll the dice, I have six possibilities only. Either I can get the value 1, 2, 3, 4, 5, or 6, right? So I have six possibilities only. So we can say that, okay, in the dice roll column, I have finite set of possibilities. Okay. And if dice roll column was my target column, and in my target column, if I have finite set of possibilities, then my model will be called a classification model. Let's take another example. Suppose I have a column called gender. Okay, and what I'm doing is I'm storing the gender value of every participant in this lecture today. So let's suppose the first participant that entered into today's meeting had a gender of male. The second participant that entered into today's meeting also had a gender of male. The third participant that entered into today's meeting had a gender of female, and so on. Okay. Now, let me ask a question to Puneet. So, Puneet, let's suppose this column, gender column, is my target column. So, Puneet, badhiya question to you. In this gender column, how many possibilities of values can we get? How many possibilities of values can we get? As Puneet mentions, two, right? Either the gender value could be male or gender value could be female, right? So, we have two possibilities. In other words, Puneet, I can say that gender column has finite set of possibilities. If gender column is my target column, and if in my target column I have finite set of possibilities, then the model will be called a classification model. Okay. Let me take one more example. Suppose I have a column like stock price. I have a column called stock price. And what I'm doing is, let's say I've bought a stock of Apple. Okay. And I'm storing the price of Apple after every day. Okay. So let's say on the first day when I bought the stock of Apple, it was $100.1. After that, it was $99.876. After that, it was $98.2 and so on. Okay. So let's suppose I have this column called stock price. Now I have a question. Let me ask that question to Hari. Hari Kishore, what do you think over here, buddy? If stock price column is my target column, then what do you think? In this stock price column, do we have finite set of possibilities or do we have infinite set of possibilities? What do you think, Hari Kishore? What do you think? Stock price column has finite set of possibilities or infinite? Hari Kishore mentioned that we have infinite set of possibilities, right? We have infinite set of possibilities. The stock price column is my target column. And in my target column, if I have infinite set of possibilities, then my model will be called a regression model. Okay. So I hope with this, the difference between classification and regression is clear to each and every one of you. Okay. With this, we have covered basics of machine learning. Now, before we move forward, just a quick revision. Okay, just a quick revision. So first question is what is machine learning? So if anybody asks you what is machine learning, you will say machine learning is a set of tools that is used for two purposes. First is to obtain inferences from data. Second is to obtain predictions from data. Then they might ask you, how do we do that? How do we get inferences and predictions from data? So you will say we get that by using something called a machine learning model. What is a machine learning model? It's a statistical representation of a real world process. In simple words, we are trying to simulate a real world process using statistics or using mathematics. Okay. Then there are two important notes to remember before making any machine learning model. First important note is that in order to make any machine learning model, we need some data, and that data needs to have some rows and some columns. So what if we have a data like image data? That image data is not in the form of rows and columns. Well, you will convert it into rows and columns. So whatever data you need that you are working on, it needs to be in the form of rows and columns. Okay, that is note number one. Note number two is that the columns in the data will be of one of the two types. Either a column will be called a feature column or a column will be called a target column. Feature columns are those columns that help me to predict. Target column is that column that I want to predict. So if let's suppose I have this data, the one that you see on your screen, and here in this data, if I want to predict price, then price will be my target column. And since square feet and city help me to predict price, they will be called my feature columns. Fine. After that, we focused on the types of machine learning models. So guys, a question over here. Do we have these two types only, the ones that are mentioned on your screen, or do we have more than two types of machine learning models? We have more than two or just these two? Just these, as Monty and Shabina Harishankar are mentioning, we have more than two types. In fact, after every 6 months, a new type comes into the market. But 95% of the work done in the machine learning industry is done on these two types only. That's why we are focusing on these two types in this lecture. So the two types that I've mentioned on your screen are first type is supervised learning model, second type is unsupervised learning model. What is the difference between supervised learning model and an unsupervised learning model? Well, in case of a supervised learning model, the data that I am using has features and target both. Whereas in case of a unsupervised learning model, what happens? In case of a unsupervised learning model, what happens? Ekta, can you answer this? In case of a unsupervised learning model, what happens? We know in a supervised learning model, the data that I'm using has features and target both. But in an unsupervised learning model, what happens? Sabina has given the answer. Sabina says, in an unsupervised learning model, the data that I'm using only has features. It will not have target. Perfect. Then we learn that supervised learning models are further divided into two types. First is classification model, second is regression model. So what is the difference between classification and regression? Well, in case of a classification model, my target column has finite set of possibilities. Whereas in case of a regression model, my target column has infinite set of possibilities. Fine. With this, we completed basics of machine learning. So guys, is basics of machine learning clear to everyone? Is it clear? Basics of machine learning. Yes, Sudarshan, Puneet, yes. Fine, everybody has mentioned yes. Fine. So I'm assuming that basics of machine learning are clear. Fine, let's move forward. So now let's focus on our main topic for this webinar, which is NLP. So as I mentioned, NLP is a subset of machine learning, right? So let's go ahead and let's talk about NLP. So guys, when can we say that we are working on an NLP problem? We can say we are working on an NLP problem when our feature column is of text format. It has text values. Okay. Or in other words, it has non-numeric values. So if your feature column has non-numeric values, okay, then what to do with it? How would you handle such a feature column? That comes under this field of NLP. And that's what we'll be doing today. Okay, fine. So let's go ahead and let's dive into it. So first we'll go ahead and we will learn the theory behind NLP. And then after that, we'll also see its practical implementation with code. Okay, so first let's cover the theory. So what we are going to today is what we are going to do today is we are going to create our first machine learning model. Okay, uh, obviously based on NLP. Okay, but let's go ahead and let's see how will we create it. Now for that, what you can do is, as you know, what is a machine learning model? It is a statistical representation of a real world process. Okay, fine. So that means you will apply some statistics, you will apply some mathematical formulas, some statistical formulas, right? Okay, fine. So you can create an algorithm of those mathematical formulas on your own, or you can use some of the ready-made algorithms in the market as well. Okay, so it's up to you whether you are creating your own algorithm for building a machine learning model, or you are using the pre-existing algorithms that are already available in the market. There are many pre-existing machine learning algorithms. You can use any one of them depending on the scenario. Uh, each machine learning algorithm will be built for a specific purpose. So let's go ahead, and in order to build our first machine learning model, we are going to take help of a pre-existing machine learning algorithm called multinomial naive Bayes. Okay, the algorithm that we are going to use is multinomial naive Bayes. So in this algorithm, there are some predefined mathematical formulas that are already in place. Okay, and we'll be seeing what are those formulas and all of that. However, if you don't want to use ready-made algorithms available in the market, you are capable enough to create your own algorithm. You can do that as well. It's completely up to you. Okay. However, since this is our first lecture on NLP, we'll be using a pre-existing algorithm. The name of this algorithm is multinomial naive Bayes. So let's talk about it. So you might wonder, this algorithm is used to build a machine learning model, correct? But which type of machine learning model? Supervised or unsupervised? Well, it is used to create a supervised machine learning model. That means this algorithm will only work only if the data has feature columns and target column both. Only if the data has feature columns and target column both. Okay. Then you might wonder that within supervised it comes under which category? Naive Bayes, multinomial naive Bayes algorithm is used for which category of supervised model? Classification or regression? Well, this algorithm is used for classification category. Okay. That means for this algorithm to work, your target column needs to have finite set of possibilities. Only then this algorithm will work. Okay. So there are other ready-made algorithms available in the market built for specific purposes. This particular algorithm is built for classification purpose. Okay. So let's go ahead and let's see how this algorithm works. Okay. So we are going to build a machine learning model using this algorithm. But let me ask a question. Okay. Let me ask a question over here to everyone. Okay. And before we go ahead, I have a doubt mentioned in the chat. So Guna Sindhu has mentioned, are these algorithms free? Yes, they are free. Yes. If they are available online, I mean, if they're deployed online, if they're open source, yes, they are free, and many of the algorithms are free. But see, there will be some companies who will create their own algorithms and they will not publish it on the internet. Okay. And they will not publish it on the internet. They will have their own patent over it and all of that. But fine. Uh, you will in the market, and if online, if you ever see an algorithm, it's published on the internet, that means it's free. It's free to use. Okay. But yes, some companies do create their own algorithms and they never show what is that algorithm, how that algorithm works. But fine. But if you say anything on the internet, you see that particular algorithm on the internet, that means it's free. Okay, it's free to use, not a worry. Anyways, fine. If it's not free to use, that company will itself not release it ever. Okay, and it will not be available on the internet ever. Fine. Going forward. Now a question to each and every one of you. Okay. The question is, I'm going to make a machine learning model using this algorithm called multinomial naive Bayes. Okay, I'm going to create a machine learning model using this algorithm. Now, the question is, in order to create a machine learning model, what are the requirements? What are the requirements? So there were two nodes that I mentioned to you. Can anybody let me know the first node in order to create a machine learning model? What is the first node? Okay, Uday and Vignesh have mentioned first note was that we needed some
Data.
data to work with, right? And that data needs to have some rows and some columns. Perfect. So let's suppose I have some data to work with over here. I have some data to work with. And in that data, what I have is, let's suppose I have one feature column only and one target column. Let's assume, although you can have many number of feature column, does not matter. But let's suppose we have one feature column, one target column. In my feature column, what I have is, I have information about various emails. Okay. So let's say in row number one, I will have text of email one. I will have text of my first email. And next to that, in my target, I will mention the category of that email, that whether it was a normal email or whether it was a spam email. Okay. Whether it was a normal email, whether it was a spam email. Fine. Like that, in the second row, I will mention text of my second email. Whatever is that text, I will mention it. Okay. And then I will mention the category of that email, that whether it belongs to normal category or spam category. Fine. So let's suppose I have some data like that. And in that data, I have information about 12 emails. How many emails? 12 emails. Okay. And out of those 12 emails, 8 emails belong to normal category, let's assume. And out of those 12 emails, 4 emails belong to spam category. Let's assume. Okay. So in total, in my data set, I have a total of 12 emails. Out of 12, 8 belong to normal category, 4 belong to spam category. Now, let's go ahead and let's see how it works. Now, let me ask a question to Uday. Now, Uday, let's suppose a email is shown to you and you are given a task to predict whether this email belongs to normal category or whether this email belongs to spam category. Can I say, in your mind, what you will do is, first, you will calculate the probability of that email belonging to normal category, and then you will calculate the probability of that email belonging to spam category. And whichever probability is higher, you will say that, okay, the email belongs to that particular category. Correct? Uday, is that what you would do? Let's say I showed you an email and I asked you whether it was a normal email or a spam email. Yes, this is something that you would do. First, calculate the probability of that email belonging to normal category. Then calculate the probability of that email belonging to spam category. Whichever probability is higher, you will say that, okay, this email belongs to that particular category. Fine. Just like Uday, you would do this. In the same manner, our multinomial naive Bayes algorithm will also do the same. So Uday, first what I will do is, first I will focus on normal emails and calculate probability of and deal with normal emails first. Then I will focus on spam emails. Okay. So let's focus on normal emails first. Okay. Let's focus on normal emails first over here. So uh, what I have done is, based on the count of the words in normal emails, based on count of the words in normal emails, I have created this histogram. Okay. So let's say in my normal email, there were only 4 unique words. Although in real life there will be many more unique words. There will be maybe 2000, 3000 unique words, or maybe even more than that. But here, just for easier understanding, I have taken a simple example. I've assumed that, suppose in your normal emails, you had 4 unique words. And based on count of the words in your normal emails, I have created this histogram. That means the word dear has occurred how many times? If you count it, you will see that it has occurred 8 times. Okay. Similarly, the word friend has occurred how many times? It has occurred 5 times in my normal emails. The word lunch has occurred how many times? 3 times in my normal emails, and so on. Okay. So I have a question. The question is, can you tell me the probability of obtaining the word dear in a normal email? Probability of obtaining the word dear in a normal email. Can anyone give me that particular probability? What will be that probability? Anyone? So, Shabina, you tell me, the word dear has occurred how many times in my normal emails? The word dear has occurred how many times if you count it? 8 times, right? Total 8 times. Perfect. Okay. Then Shabina, in my normal emails, can you tell me the count of all the words? Can you sum the total of all the words? So dear has occurred 8 times, right? Friend has occurred 5 times. Lunch has occurred 3 times. Money has occurred 1 time. So as Hari Kishore is mentioning, total number of words is 17. So probability of obtaining the word dear in a normal email will be 8 by 17. As mentioned by Pushpendra, Divya, Shabina and Hari Kishore, the probability of obtaining the word dear in a normal email will be 8 by 17. Okay, fine. Now let's go ahead. Similarly, one second. I'm not able to see your chat side by side. I wanted to see your chat as well. One second, I'll have to do that setting somehow. Okay, for some reason, I'm not able to see your chat side by side. I have to always come. Okay, I guess now it's fine. Or is it not? Let me try. Okay. It's fine. Okay. Let me proceed. Fine. So as you mentioned, guys, probability of obtaining the word dear in a normal email is 8 by 17. Perfect. Now let's move forward. Similarly, uh, similarly over here, I have a question. What is the probability of obtaining the word friend in a normal email? Can anybody let me know? What is the probability of obtaining the word friend in a normal email? Shivam, what do you think, buddy? Probability of obtaining the word friend in a normal email. So Pushpendra, Hari, Monty, Puneet, Sudarshan, everybody. Right, everybody has given the correct answer. All of you guys have said probability of obtaining the word friend in a normal email will be 5 by 70. Perfect. Okay. Similarly, probability of obtaining the word lunch in a normal email will be, Divya, what will it be? Probability of obtaining the word lunch in a normal email? 3 by 17, right? As Pushpendra, Divya and Shivam have mentioned, 3 by 17. Okay. Similarly, Sunita, what is the probability of obtaining the word money in a normal email? Probability of obtaining the word money in a normal email, as you guys have mentioned, 1 by 70. Perfect. Now, just like I've dealt with my normal emails, similarly, let me deal with spam emails. So based on count of the words in spam emails, I have created this histogram. Okay. Now, I want you guys to let me know what is the probability of obtaining the word dear in a spam email. So, Tapan, can you let me know, buddy? Probability of obtaining the word dear in a spam email. You guys have mentioned, Pushpendra has mentioned 2 by 7, right? The word dear in a spam email has occurred 2 times. Out of how many times? Total number of words in my spam email is 7. So probability of obtaining the word dear in a spam email will be 2 by 7. Probability of obtaining the word friend in a spam email will be 1 by 7. Then probability of obtaining the word lunch in a spam email will be 0 by 7. 0 by 7 means 0 only, right? Okay, and so on. Fine. Similarly, I will calculate probability of these words belonging to spam category. Fine. Perfect. Up till here, making sense, guys? Up till here, making sense? Tapan, Shivam, Sudarshan, everybody else. Making sense up till now? What I have done? I have calculated the probability of the words belonging to normal category and probability of same words belonging to spam category. Now, a question. So I described my data set earlier to you that in order to build a machine learning model, I'm going to have a data set. In that data set, as I mentioned, I had a total of 12 emails. Out of 12 emails, I said how many belong to normal category? Out of 12, how many belong to normal category? 8, as Sudarshan mentions 8. So Sudarshan, what is the probability of obtaining a normal email out of all the emails? Probability of obtaining a normal email out of all the emails? Total number of emails were 12, out of which emails belonging to normal category were 8 only. So probability of obtaining a normal email will be 8 by 12. Perfect. As Divya, Sunita and everybody else have mentioned, 8 by 12. Right? Okay. Perfect. 8 by 12. Similarly, out of 12 emails, spam emails have occurred 4 times. So probability of obtaining a spam email will be 4 by 12. Okay, fine. Now let's move forward. Now suppose I have received an email. I have received an email and I want to predict whether that email belongs to normal category or whether that email belongs to spam category. So just like when I asked Uday earlier, I asked to Uday that suppose if I showed you an email, how will you know? How will you predict whether it belongs to normal category or spam category? So he mentioned that maybe first what he will do, he will calculate the probability of that email belonging to normal category, then probability of that email belonging to spam category. Whichever category is higher, he will say that that particular email belongs to that particular category. Okay, let's see. So let's suppose I have received an email called hello friend. Let's suppose 2 words only. Okay, for simpler explanation, I have assumed that let's suppose you have obtained an email having only 2 words. Hello friend. Now what I will do, I will calculate probability of this email belonging to normal category and then probability of the same email belonging to spam category. Let's see which probability is higher. Remember here when I will calculate probability, I will use a formula called Bayesian formula. And with Bayesian formula, it's not necessary that your probabilities will sum up to 1. Normally what happens, the probabilities sum up to 1. Let's say if we have a match between India and England, then if I ask you to calculate probabilities, you will say chances of India are winning are 0.8, that means 80%, and chances of and probability of England winning is 0.2 or 20%, right? So in that case scenario, what is happening? Probability of India is 0.8, probability of England is 0.2. Their probabilities are summing up to 1. Okay, but in Bayesian formula that is not the case. But anyways, let's see how it works. Okay, so suppose I have received an email called hello friend. First I will calculate the probability of that email belonging to normal category. So first I will get probability of obtaining a normal email into probability of obtaining the word dear in a normal email into probability of obtaining the word friend in a normal email. I will just substitute the probability values and at the end I get a result of 0.09. So this is the probability of this particular email belonging to normal category. Okay, belonging to normal category. Similarly, let me calculate the probability of this email belonging to spam category. Okay, so what I will do, I will have probability of obtaining a spam email, probability of obtaining a spam email into probability of obtaining the word dear in a spam email into probability of obtaining the word friend in a spam email. I'll just substitute their probability values and at the end the result that I get is 0.01. And as you can see, the probability values don't sum up to 1. If you take the sum, it won't sum up to 1. Normally what happens with other probability formulas, when you calculate probabilities, they sum up to 1. But with Bayesian formula, it is not the case, as I mentioned earlier. But fine. Now, I have a question to each and every one of you. What do you think? Which probability is higher? Probability of the email belonging to normal category or probability of the email belonging to spam category? Which one is higher, guys? Normal or spam? Normal or spam? Normal, right? That's why my model will predict that, okay, this particular email belongs to normal category. Okay. Suppose over here one student is asking, let's suppose that word has not occurred at all previously. Then what will it be its probability? Okay. If that word has not at all occurred previously, then its probability will be what? For example, in case of I guess there was some particular word which has not at all occurred. Okay, then what will it be? Its probability? Its probability will be equal to 0 in that case. Okay, now based on this query that this person has asked, this is a good query that this person has asked. Based on this, okay, let's suppose you have some words that have not that the model has not at all seen before. In that case, you might have some problems. Okay, what are those problems? We'll see. Okay, but to answer a question in short, in that scenario, the probability of that word will be treated as 0. But because of that, what all problems we'll have to face? Let's go ahead and let's see it over here. Okay. But anyways, over here, we wanted to see the working of our first machine learning algorithm called multinomial naive Bayes. And how multinomial naive Bayes does its prediction? Is it clear to everyone? How it does its prediction? Is it clear to everyone? Make sense? Yes? Okay, fine. Now, this was the theory. You might wonder how to implement this in practice. So let's go ahead and let's see, guys, how to implement it in practice. Okay, we'll see how to implement it with code. Okay, so what I will do is I will open up Jupyter Notebook, which is a tool using which I will be writing my code in Python programming language. You can use any other tool as well, does not matter. But here I prefer this tool, okay, because it's much easier to work with. Okay, here my tool is opened. Now what I will do is I'll create a new file, and in that file I'll be writing my code. Fine, let's go ahead. Now remember that whenever you are building a model, okay, whenever you are building a model that comes under supervised category, okay, whenever, or I should say in other words, whenever you are implementing an algorithm under supervised learning model category, then you need to follow the below steps. First step that you will follow is to make sure that the data is clean. That means it does not have any spelling mistakes. Let's say some value don't have spelling mistakes. Okay. Then you should make sure you don't have any missing values. Okay. So those are the things that you will check for over here. Okay. That data should not have any missing values. Okay. It should not have any incorrect values, and all of that you will try to validate. Fine. That is what you would do in step number one. What would you do in step number two? Step number two is to extract features and target separately. Okay, extract features and target separately. Step number three is to make sure that our features are of numeric nature. If they are not numeric, we will convert it to numeric. Okay, if my feature column is non-numeric, I will convert it to numeric. Fine. Fourth step then is to make sure that our features have some rows and some columns. Okay, this might seem like a very basic step, okay, but it's not basic. Going forward, I will show you a scenario where this step does not satisfy, and in that case, what happens? I will show you. Okay, what all problems you get while implementation. Okay, so it's not basic. Okay, whatever steps I'm writing are not basic. You should not neglect any step over here. All of them are important. Fine. Then fifth step is to basically split the data into two parts, training and testing. Then sixth step is to make sure that we train the model on the training data set. And then the seventh step is to make sure that we test the model on the testing data set. On the testing data set. Fine. So these are the steps that you need to implement. Let's go ahead and let's implement them one by one. But before that, we need some data. So let's go ahead and let's obtain our data over here. So what I have with me is I have data of some tweets. Okay, I repeat, I have data of some tweets. On Twitter, you can write tweets, right? So I have data of some tweets. And particularly, I have information about tweets of Donald Trump and Justin Trudeau. Okay, so I want to train my model in such a way that if at all I show it a tweet, it should correctly predict whether that tweet was written by Donald Trump or whether that tweet was written by Justin Trudeau. Okay, I want to build a model that accurately predicts whether a tweet was written by Donald Trump or whether that tweet was written by Justin Trudeau. Fine. So for that, I need to have a data set. So let's go ahead and let's obtain that data set. I already have my data set in D drive. Inside D drive, I have a folder called datasets. Inside that folder, I have a file called trumptrudeau.csv. Okay. CSV, remember, stands for comma separated values file. Anyways, over here we'll get data from it. And currently I have an error. It seems that there is some spelling mistake. I will correct that spelling mistake, and after that this code will work. So it's just that my file name previously was wrong. I had forgotten to mention this R in Trump. I had forgotten to mention. Okay, so because of that wrong file name, we got that error previously. Anyways, now it works. Let's have a look at the data. This is our data. Okay. Now what I'm intending to do is I'm intending to use this particular column as my feature column. Okay, this column contains my tweets. Okay, and this second last column, I'm intending to use it as my target column. Okay, currently in my target column, there are only two possibilities, either Donald Trump or Justin Trudeau. Okay, so if in my target column there are two possibilities, or if in my target column I have finite set of possibilities, then my model will be called a classification. And we know that the algorithm that we studied just now, multinomial naive Bayes, is used for classification purposes. So it could be a good fit over here. Fine. All right. Let's go ahead. First step. First step is to make sure that data is clean. And there are many things to look into whether data is clean or not. But one of the major things that you will look into is you will check that data should not have any missing values. Let's check whether it has any missing values or not. On checking, we observe that in the first column, there are zero missing values. In the second column, there are zero missing values. Similarly, in other columns also, there are zero missing values. Perfect. There are other things that you will look into. You will look for spelling mistakes and all of that. But fine, today we don't have time for it. So we'll not do it. Anyways, I've already done that check earlier. I know that this data is clean. There is no spelling mistake. I've already done it. Okay, but fine. Let's move forward. Now, second step. Second step is to make sure that we extract the features and targets separately. So let's do it. So from this data, we know that author column is my target column. Okay, it is my target column. So let me separate it, and I will separate this target column over here. And this last column, which contains my tweets, is my feature column. Okay, so that last column is my feature column. So let me have that separately as well. Okay, fine. So I've done this. I've extracted my features separately. I've extracted my targets separately. Uh, for you guys to understand this correctly, let me give it a meaningful variable name. So I'll call it target, and I'll call this variable as feature. Okay, so it's a meaningful variable name so that you guys can understand better. Okay, second step done. Now, third step, guys. Third step is to make sure that our features are of numeric nature. Okay, let's go ahead. Guys, how many feature column do I have with me currently? Ankit, how many feature column buddy do I have?
Yes. Actually, except for author and state we have ID column. So ID will be the feature column.
No. Currently, I felt that these two columns were useless. Okay. So I didn't treat them either as a feature. I didn't treat them a target as well. They were useless. I didn't consider them at all. What I did was this last column, I had it as my feature column. And this second last column, I had it as my target column. Okay.
Okay.
So now, buddy, you tell me how many feature column we have over here? One.
One, the last one.
One, correct? Okay. And
So
have a look at that particular feature column. You have that one feature column. Have a look at it. There's that one feature column over here. Fine. In the first row, there's the value in that feature column. In the second row, there's the value and so on. Okay, fine. Have a look. Are the values numeric or non-numeric?
yes.
What do we have? Non-numeric. So if the features have non-numeric values, we have to convert it into numeric values. Our features should be of numeric nature only. If they are not of numeric nature, we'll convert it into numeric. Let's see how. Let's go ahead and let's see how. So guys, if your feature column is non-numeric, okay, it is non-numeric, and within non-numeric there are two type of non-numeric columns. Either it could be a discrete non-numeric column, A discrete column means a column having finite set of possibilities, or it could be a continuous non-numeric column. A continuous column means a column having infinite set of possibilities. Okay. So for example, let's assume I have a column with me called gender. Now gender is a non-numeric column, but within gender, do I have finite set of possibilities or infinite set of possibilities?
Yes, correct. Finite.
Finite, right? Within gender, I will have two possibilities, either male or female. So within gender, I have finite set of possibilities. So that means gender is a non-numeric column, but which type of non-numeric? Discrete non-numeric. Okay. On the other hand, let's suppose I have a column called YouTube comments. One second. Let's suppose I have a column called YouTube comments, and let's suppose I have a YouTube channel. And in that channel, whatever comments come, I am storing it in this column over here. Okay. So let's suppose people have written their comments. Now you let me know, guys, do I have finite possibilities for YouTube comments or infinite set of possibilities?
Infinite.
Finite or infinite? Infinite, right? A person can put any comment on YouTube. There is no finite set of possibilities available, right? There are infinite set of possibilities. A person can type anything. Okay. So YouTube comments, if there is a column like that, that column will be a non-numeric column. Okay. But which type of non-numeric? Continuous non-numeric. Why? Because it has infinite set of possibilities in it. Okay. I'll do one thing. I will unmute the mic of participants. Guess it's unmuted now. Sorry, not unmuted. I wanted to mute them. I guess it has been muted. Okay, I could hear some background noise, so fine. Anyways, let's move forward, guys. Okay, fine. So features, we wanted it to be of numeric nature. Now you have to check whether it is discrete non-numeric or continuous non-numeric. If it is discrete non-numeric, then you have some techniques that you can use. One of the techniques is called one-hot encoding. Other technique is dummy encoding. Okay, one-hot encoding and dummy encoding. These are the two popular approaches used if in case you have a non-numeric feature column of discrete nature. On the other hand, if you have a non-numeric feature column of continuous nature, what all techniques can you use? You can use many techniques. However, the two most widely used techniques are these, the ones that I'm going to mention. The first is count vectorizer, and second is TF IDF vectorizer. TF IDF vectorizer. TF IDF vectorizer. Okay, fine. So remember that depending on the nature of your non-numeric feature column, you will choose the technique of your choice. Okay, so a question to everyone. Currently, in my data set, have a look at my non-numeric feature column. It is this non-numeric feature column, just one non-numeric feature column only, okay, which contains tweets. So have a look at this non-numeric feature column and let me know, is it of discrete nature or continuous nature? Is it of discrete nature or continuous nature? Shabina says continuous nature. Perfect. So Shabina, that means I can use either count vectorizer technique or TF-IDF vectorizer technique. Okay. Let me show you how count vectorizer technique works. And using count vectorizer, how can you convert a non-numeric column to a numeric column? Let's see. Okay. So we'll first see how count vectorizer works. Let's see it. Let's see how it works. So suppose I have a non-numeric feature column over here. I have a non-numeric feature column, and in that I have two rows. Okay, in the first row, let's say I have a tweet saying that um, cricket is exciting sport. In the second tweet, someone has written sport of cricket is a uh, exciting sport. Okay, fine. Now, I will need your help, guys. So let me take help of Sudarshan. So Sudarshan, you let me know now. The question to you, Sudarshan, is in this feature column, okay, you can see in the first row we have this particular value, in the second row some other value. Now, can you tell me in my feature column how many unique words do we have? Words, unique words. Let's count. Okay. So Sudarshan, so for example, cricket over here is a unique word. Ace is a unique word. Exciting is a unique word. Sport is a unique word. Off is a unique word. This is not unique. Even this is not unique. Yes, this is a unique word. This has already occurred previously, so not unique. Even this has already occurred previously, so not unique. So in total, if I just count, can I say, Sudarshan, that I have 6 unique words in total?
Yes, we can call it out
Yes,
as six unique words.
correct. 6 unique words. So since I have 6 unique words in my feature column, that's why I will create 6 new columns. First unique word was cricket, right? Second unique word was is, third unique word was exciting, fourth unique word was sport, fifth unique word was off, and sixth unique word was a. The other words were not unique. Fine. So for each unique word, I will create a new column. For each unique word, remember, we'll create a new column. Let's do that. And let's see after that what to do. So for every unique word, I'm creating a column. So like that, let's suppose if there are 2000 unique words, I'll create 2000 new columns. Okay. If there are 2000 unique words, I'll create 2000 new columns. Remember that. Okay. Fine. Now, Sudarshan, please help me out. In the first row, the word cricket has occurred how many times?
One time.
One time. Perfect. So over here, we will write 1. In the first row, the word is has occurred one time. In the first row, the word exciting has occurred one time. But
One
Sudarshan, in
time.
the first row, the word sport has occurred how many times?
Zero times.
0. So over here, I'll write 0. Then in the first row, the word off has occurred 0 times. In the first row, the word a has occurred 0 times. Similarly, let's move forward. Now in the second row, the word cricket has occurred one time. In the second row, the word is has occurred one time. In the second row, the word exciting has occurred one time. In the second row, Sudarshan, the word sport has occurred how many times?
Two times.
2. So over here I'll mention 2. Similarly, in the second row, the word off has occurred one time. In the second row, the word a has occurred one time. With this, have a look, Sudarshan. Have I converted my non-numeric values to numeric values now?
Yes.
Yes. In the process, yes, we ended up with more columns than what we had before. I agree with that. But at least we have converted our non-numeric values to numeric values. Okay. So this is the technique of count vectorizer. Okay. Remember, this is count vectorizer technique. Fine. Let's go ahead and let's try to apply it. Remember, if your non-numeric feature column is continuous in nature, you can use count vectorizer or TF-IDF vectorizer. Uh, since today we don't have time to cover TF-IDF, I won't talk about it. Okay, but it's slightly different to count vectorizer, and based on the working, when based on the scenario, you have to choose whether to prefer count vectorizer or TF-IDF vectorizer. But anyways, today let's only focus on count vectorizer. Okay, and let's see how it works. Let's see. Let's see how to implement. We already know the theory of it. What I will do is now I will show you the implementation of this. So what I will do is from sklearn folder, there is a file, or I should say there is a subfolder called feature extraction. Inside that subfolder, I have a file called text. And from that file, I have this class called count vectorizer. Okay. Now I will go ahead and call this Python class. Okay. So that it is ready to perform the technique over here. It's like I'm waking up the technique. Okay. With this, my count vectorizer technique will wake up in simple words. After it has woken up, we will say that, okay, please go ahead and apply your changes, whatever you want to do on your feature column. Okay. We wanted to convert our non-numeric feature column to numeric feature column, and this code will do it. Okay, and this particular code will do that job for us. Fine. And now our non-numeric feature column will be converted to numeric feature column. Okay, it will be converted to numeric feature column. Fine. All right. Let's go ahead. Now that my third step is done, let's move on to step number 4. Let's see step number 4. Okay. Before that, I'll just mute the other participants as I can hear some background noise. Okay. I've muted them. All right, let's move forward. Step number 4, guys. Step number 4 is to make sure is to make sure that features have some rows and some columns. So let's check whether they have some rows and some columns or not. Okay. So what I would do is I will just check whether they have some rows and sorry, my feature, right? So my feature, I'll just check if they have some rows and some columns. And yes, we have 400 rows and 2500 columns. Over here in this feature column, there were 2500 unique words. So for those unique words, 2500 new columns were created. Fine. So now my features has 400 rows and 2500 columns. Okay, fine. So my features do have some rows, some columns. Fourth step is done. Okay, we are not concerned about the number of columns. That's fine for us. Okay, now let's move forward. The next step is to split the data into two parts, training and testing. So let's go ahead and do it. Let's split the data into two parts over here, training and testing. So from the sklearn folder, there is a file called knife base called, there's a file called model selection, I should say. And inside that file, I have a function called train test split. Okay. I will just go ahead and call this function. And inside, first I will pass my feature column. Then next I will pass my target column. Okay. And I will also mention the ratio in which I want to split my rows and training and testing. Okay. Remember, let's say if we have 100 rows, out of those 100 rows, how many rows you wanted training data, how many rows you wanted testing data, that you will have to remember, that you will have to mention. Okay. So let's say out of 100 rows, do you want 80 rows in training, 20 rows in testing, or what is that ratio? You need to mention that. So let's say I'm mentioning that 20% of my overall data should go for testing. Okay. So what will happen? 20% of my overall data will go for testing. So here's a value of 0.2 means 20% of my overall data will go for testing and the remaining 80% will automatically go in training. Okay. Now, what is the purpose of dividing the data into training and testing? So what will happen is, let's suppose I have a feature column which contains tweets and then I have a target column. Okay. Let's suppose I have mentioned some tweets, tweet 1, tweet 2, tweet 3, tweet 4, tweet 5. Okay, and I've mentioned that whether this tweet was made by Trump or Trudeau. Let's say we have data like this. Now, what I could do is I could split this entire data into two parts. Some of the rows will go into training, the remaining rows would go into testing. Okay, so let's suppose I want it like this, that let's say 60% of the rows go into training. So out of 5 rows, if 60% rows go into training, that means out of 5, 3 rows will go into training. Okay, so let's suppose the first 3 rows go into training. Remember that by default, what happens is when you say that, okay, you want these percentage of rows into training and testing, it's not like always the first rows will be taken into training data set or the last rows will be taken into testing data set. No, the selection of rows into training and testing is done randomly. So yes, let's suppose I want 3 rows in training, but it's not necessary that always the first 3 rows will be obtained in training. Maybe we could have these 3 rows in training. Maybe we could have these 3 rows in training. Okay, the selection is done randomly. Fine. With that out of the way, let's suppose I have some rows in training data set, some rows in testing data set. So the idea is that we'll train the model on the training data set. The model will be exposed to the training data set. Once it trains on it, okay, once it trains on it, once it applies the algorithm that we are intending to apply, all of that, we will now move on to our testing data set. And then we will ask the model to give us predictions for the target in the testing data set. So let's say for the first row in the testing data set, it has given a prediction of trudeau. Let's say for the next row in the testing data set, it has given a prediction of trudeau as well. Okay. Now I have a question. Let me ask that question to Uday. So Uday, what do you think? Have a look at the first row of the testing data set. The actual target value was Trump, but the model predicted it to be Trudeau. So the prediction was not correct, right? So over here, the prediction was not correct. However, what about the second row in the testing data set? The actual target value was Trudeau and model also predicted it to be Trudeau. So here I am getting correct predictions on my testing data set. So if at all I want you to give me the model performance, what will you say? That on the testing data set, what is the model's accuracy? In my testing data set, I have two rows, let's say. Out of two rows, only one row was correctly predicted by the model. So the accuracy was 0.5, in percentage terms, 50%. Okay, right? So that's the goal of splitting the data into training and testing. That will only train the model on the training data set, and we will test it on unseen data set, like testing data set. Testing data set is not shown previously to the model. Okay, it is only shown while testing it. Okay, so we train on a different data set, test on a different data set. Fine. Okay, let's go ahead and let's implement this code over here. So over here, what I will have is I will first my feature will be divided into two parts, and I will have uh, feature of my training data set and feature of my testing data set. Then I will have my target divided into two parts. So I will have target in my training data set and target in my testing data set. Okay, fine. With this, fifth step is done. Now let's move on to step number 6. Step number 6 is to make sure that we train the model on the training data set. So let's do it. So for training a model, what is the algorithm that we'll use? Well, we'll use a ready-made algorithm available in the market called knife base. Okay, so what I will do is I'll try to import it over here, that ready-made algorithm. You can build your own algorithm as well, not a issue. Okay, or you can use any ready-made algorithm available in the market. Fine. So I'm using a ready-made algorithm, the one that we studied earlier called multinomial naive Bayes. So from sklearn folder, there is a file called knife base. And from that file, I will import this class called multinomial NB. Okay. Now let me go ahead and let me call this class. With this, I am suggesting that this is the algorithm to use. Okay. Now, what I want to do, I want to train my model on the training data set. So, uh, in order to train the model, what should we do? It's like, let's say, if I ask you to train on a textbook, that means I want you to scan the contents in the textbook, right? Similarly, if I want the model to train itself, that means I want my model to scan something. In machine learning, another word for scanning is fitting. Okay, so fitting in machine learning is also known as scanning. So what it will do is it will scan the content that we want. We want to train the model, or we want the model to scan something. Scan what? We want it to train on the training data set. So we want it to scan the training data set. Fine. So over here, a question. Let me ask that question to Ravi. So Ravi, out of the four things that I got after train test split, what all things belong to my training data set? Out of the four things that I got out of train test split, which things belong to my training data set? Remember, we want to train the model only on the training data set. So out of these four things that you got out of train test split, which things belong to training data set? It's written in their names. It's written in their names over here, right? As Ravi mentioned, it's written in their names. The same things over here will pass into our code. Fine. So over here, what we are doing, we are training the model on the training data set. Fine. Then a training is done. Okay. Here we had to train on very less number of rows. In total, I had 400 rows, out of which 20% I wanted in testing. So out of 400, if 20% goes in testing, that means 80 rows should go into testing, and only 120 no, oh, sorry, only 320 rows will go into training. Okay, so my model was only trained on 320 rows, very less number of rows. That's why you see training was done very quickly. Okay, as the number of rows in training data set increases, your training time will also increase. Fine. Now, last step. Last step is what? To test the model on the testing data set. So let's test. Okay. So I want to calculate the performance of the model on the testing data set. So I want it to give me an accuracy score. Remember, accuracy is number of correct predictions divided by total number of predictions. Okay. Divided by total number of predictions. Fine. So let's say out of let's say it did 100 predictions. Okay. Out of 100, only 80 were correct. So the accuracy will be 0.8. Okay. Or in other words, in percentage terms, 80%. Okay. Fine. So remember, accuracy will be between 0 to 1. And let's go ahead and let's calculate it. We want to test the model on the testing data set. Out of the four things that I got after train test split, which belongs to my testing data set? These two, the ones that I have highlighted over here. Okay, so I'll pass these things in my testing data set. Let's go ahead, let's pass it. Let's pass. And with that, I'll get accuracy score between 0 to 1. For your model to be acceptable, your accuracy score should be at least greater than or equal to 0.7. Here, let's see if it's greater than or equal to 0.7. Yes. Okay, fine. Now, how can I make my model performance more better? Okay, let's go ahead and let's see the how can I make it more better over here. So what can I do? Okay. Now, let me show you that technique with which I can make my model performance more better. And that technique is called stratification technique. And that is the one that we need to apply during train test split. You can see when I did not apply it, you can see it was slightly low. Performance was slightly low. Let me apply stratification. The idea is, okay. And by the way, let me show you the problem that will arise without stratification. So let's say I have my target column in which I'm mentioning that let's say I have a telescope at my home, and every day through my telescope I'm trying to see a planet, and I'm trying to find Mars planet using my telescope. Let's say on the first day I did not get a Mars planet, so I have mentioned not Mars. On the second day I did not get a Mars planet. On the third day also, let's assume I did not get a Mars planet. Similarly, on the fourth day, I did not get a Mars planet. However, on the fifth day, I got to see a Mars planet. On the sixth day also, I got to see a Mars planet. Similarly, on the seventh and eighth day also, I got to see a Mars planet. Okay, so I have my target column in which there are only two possibilities, either not Mars or Mars. Fine. Now, let's suppose what I am doing is I am wanting some rows in training data set, some rows in testing data set. Okay. Some rows in testing data. So let's say what I want is I want 4 rows in training, 4 rows in testing, or in other words, 50% of the rows in training, 50% of the rows in testing. Let's say I want something like this. Okay. So in total, I have 4 rows, 50% of, sorry, in total, I have 8 rows, right? 50% of 8 is 4. So 4 rows will go to training data set, 4 rows will go to testing data set. Guys, how does it happen? Always the first few rows go into training, last few rows go into testing. Is it like that? Or is the selection done randomly? Or is the selection of rows into training and testing done randomly? Sudarshan says, no, it's not like always the first few rows go into training, last few rows go into testing. Selection is random, right? As Yuda and Sudarshan have mentioned, it's random. As Vignesh has mentioned, it's random. But Vignesh, even in random selection, just a question to you, Vignesh, even in random selection, is there a possibility that first 4 rows go into training and last 4 rows go into testing? Is there a possibility that something like this might happen? Possible? Yes. Okay. Now, Vignesh, a question to you, or let me ask that question to Ravi. Ravi, can I say that you only know those things on which you are trained? Yes or no? You only know those things on which you are trained. You might be trained on it in your school time, your college time, on the internet, in real life, or in office, right? You only know those things on which you are trained, right? Other things you don't know. For example, me, I only know those things on which I am trained. Other things I would not know. For example, I'm not trained on aeronautical engineering, so I don't know anything about aeronautical engineering. Okay, so I only know those things on which I am trained. Similarly, the model will also know those things on which the model is trained. My model is trained on how many rows? It is trained on 4 rows over here. In any of the 4 rows, did we pass even a single example where the planet was a Mars planet? In any of those 4 rows, did we pass even a single example? Remember, rows will also be called examples. Okay. Remember, rows in training data set are also called examples. Okay. So in the 4 examples that you have given in the training data set, or in the 4 rows that you have given in the training data set, is there even a single example where the planet is a Mars planet? No. If in the training data set there is no mention of Mars, will my model know that such a planet called Mars exists? If during training you have not even passed a single example like that, then will your model know that such a thing exists? It won't know. So my model won't know in this scenario that such a planet called Mars exists. If it does not know that it exists, how will it predict it? It will never be able to predict it. This is a big performance issue. It will never be able to predict Mars. Why? Because in the training data set, we have not even passed a single example of a Mars planet. So my model won't know that such a thing exists. If it does not know such a thing exists, how will it predict it? It will never predict it. That's why we have a technique called stratification. And the idea behind stratification is that the proportion of target column, the proportion of values present in original target column should be the same as the proportion of values present in proportion of target values present in training and testing data set. Okay, fine. Let's go ahead and let's see how will it work, guys. Let's see how will it work. Fine. So now what I will do is, apart from maintaining this train test split ratio, I will also try to maintain this stratification ratio. Stratification says that the proportion of target values present in the original target column should be the same as proportion of target values present in training and testing dataset. Okay. So in my original target column, there are two unique values, not Mars and Mars. Now, I have a question to Ankit. Ankit, the value not Mars has occurred how many times in my original target column?
5.
Uh, Not Mars.
4, 4. Sorry,
Okay.
4.
So can I say in 50% of the rows, not Mars has occurred, correct?
Hmm.
And in the remaining 50%, Mars has occurred. So the
Hmm.
same proportion that is there in original target column, the same proportion should be there in training and testing dataset also. Okay, that is what stratification says. So now what will happen is, yes, I want 4 rows in training, 4 rows in testing, just like earlier. But now what could happen is something like this could happen. Maybe we could have these 4 rows in training. We could have these 4 rows in training. So now what stratification will do is, yes, it will satisfy your train test split ratio, but it will also take care that the proportion of target values present in the original target column that is there, that same proportion is present in training and testing data set as well. Fine. So let's say over here, these are the 4 rows in my training data set, and the remaining 4 rows will be in your testing data set. Fine. And all right, now let's have a look. Remember, your model will only be trained on your training data set. Now have a look, Ankit. In your training data set, have a look. In my training data set, first of all, Ankit, tell me this. Do we have 4 rows in training, 4 rows in testing? Is this done?
Yes.
Yes. Now, in the training data set, is Mars and not Mars occurring 50% of the times?
Yes.
Yes. In testing data set, is Mars and not Mars occurring 50% of the times?
Yes.
Yes. So stratification ratio has also been satisfied. With this, let's see whether a problem got solved or not. Earlier, a problem was in the training data set, we were not even passing a single example where the planet is a Mars planet, right? So my model did not know that such a thing like Mars existed. If it didn't know that such a thing called Mars exists, how will it predict it? It will never be able to predict. But now have a look, Ankit. Have we passed examples of both Mars and not Mars in the training data set?
Mm-hmm.
Yes. So now your model is aware about both the possibilities. So now your model will be able to predict both Mars as well as not Mars. Okay. So let's apply stratification. Remember, stratification needs to be applied on target column. Okay. So over here, we'll do this. We'll apply stratification on target column. And let's see. Previously, our accuracy was 0.82. Hopefully now it's better. Can you see the performance increase now? Okay, from 0.82, the performance is increased. Fine, we can even make the performance more better, but fine, that's for another day. Over here, anyways, we have created a machine learning model. Ankit, why did we create a machine learning model for time pass? Or what is the purpose of creating a machine learning model? We studied it earlier. A machine learning model is built for two purposes. What are they?
Inference and prediction.
Perfect. Inference and prediction. Let's say I want to use it this time for prediction purposes. So I have a tweet saying CNN is fake news. And what I want to do is I want to predict who is going to make this tweet. So guys, if you follow geopolitics, who is more likely to make this tweet, Donald Trump or Justin Trudeau? If you follow geopolitics, you would know. Who is more
Trump.
likely to do this? Trump, right? Trump is more likely to do this. So let's see if our model also thinks the same. But remember, before we do prediction, before doing prediction, there are 2 points to satisfy. Okay, there are 2 points to satisfy over here. First point is, first point, the same changes